This is the video lecture for Math 3, Unit 2, Objective 7. So this is our notes. So what we're going to be looking at is solutions of functions. So this is kind of related to the graphing component, and we're definitely going to be checking on vocabulary, where we're going to be looking at just not only the words, but the symbolic notation as well. So in particular, we want to take a look at x-intercepts, y-intercepts to review that idea. So x-intercepts can be referred to as roots and zeros, so those are interchangeable words. Sometimes we refer to, what are the zeros of the functions when we're looking at equations, or if we're trying to graph, we'll say oftentimes what are the x-intercepts of this particular function. So sometimes we'll use the words specific to, am I given a graph or an equation? But they are interchangeable. So what is an x-intercept? So that specifically is where your function would cross the x-axis, right? So where your function crosses the x-axis. And that's always going to occur when your y value is equal to 0, right? So if your y value is equal to 0, for example, so keeping in mind this is your y-axis here, right? So if y is equal to 0, that means you're not going to go anywhere on the y-axis. You're not going to go up, you're not going to go down. You're going to stay right on this level line here, which would be your x-axis, which would give you your x-intercepts. And then you could also write that, of course, as f of x is equal to 0. And that would be in your function notation, right? So these are similar to each other as well, right? So function notation, or just stating that the y value is equal to 0. You also have our y-intercept, so we're going to be looking at that as well. So for your y-intercept, so that is where your function, so graphically, is going to cross the y-axis, so where it crosses the y-axis. So that would be when x is equal to 0, so specifically, right? So if x were equal to 0, so this is our x-axis, and if x were 0, you're not going left or right anywhere, you're staying right here on this line. And so this sometimes can be confusing when you see this format here, so where y is equal to f of 0. But again, because it's in function notation, that is usually where your x is, right? And we replaced x with 0. So that's just still saying that kind of same thing as this here as well, right? So this is sometimes a little bit different, but specifically they're saying when that number is 0, then that is your value for x, and then so that's when x is equal to 0, okay? All right, so let's go ahead and take a look at this first example. And so let's just kind of look at the graph first. So we have two things that we're working with, right? We've got f of x. So f of x is this graph right here. So I'm going to go ahead and just kind of trace it out. So it's going to be, well, I didn't do a good job there, but so there is our red graph, right? So that is going to be our red graph. And then we have our g of x. So I'm going to go ahead and highlight that. So g of x is this linear graph right here. So we have this curve here, so this would actually be a cubic. Okay, that's in red, and that's labeled f of x. And then g of x is this linear graph, and that's highlighted in yellow. So if I look at f of x, I can see that there are dots on f of x, right? So we don't have everything labeled on f of x. We couldn't do that. But we have a handful, right? So we have a is on f of x. We see that c is on f of x. So is e. F is on f of x, but if you look, it's also on g of x. And then we have g as well. Okay, so that is just in general, right? That's our picture. So then we have some questions that we have to answer about that, okay? So our first question is we are listing all of our labeled points, so our labeled points that are solutions for where f of x is equal to 0. So what does that mean again? So when f of x is equal to 0, so if I look up here, so if I look for where f of x is equal to 0, so that's in this side over here. So f of x is equaling to 0, remember that means that our y value is 0, and if our y value of 0 is 0, that's where it crosses the x-axis. So what are we looking for? So we're looking for x-intercepts, right? So when we see that f of x is equal to 0, that part right here, we are looking for x-intercepts, okay? So on f of x, so f of x is my red graph, so I'm looking for the x-intercepts where it is labeled. So that would be where is it hitting the x-axis, so that's here and here, right? Those are the only two labeled. So there is this kind of third option, right? But see how it's not labeled, it doesn't have a dot with a letter next to it. So that's on a labeled x-intercept. So in this case, only A and G are going to be solutions. So our labeled points would be A and G. All right, so let's go ahead and take a look at the next question. So here they're wanting to list again the labeled points only for where g of x is equal to f of x. And we've done this a couple times, not just in chapter 2, but you did it, you know, in previous math classes as well. So whenever we're looking for where g of x is equal to f of x, remember that is looking for intersections, right? Where do the two graphs intersect? Okay, so where do they intersect? So where does the highlighted linear line intersect with the cubic? So if I look here, there's an intersection here, but it is not labeled. There's another intersection here, also not labeled, and one more intersection right here, which is labeled, and so that is at letter F, right? So again, there's actually 3 intersections, 3 places where they're equal, but there's only one that is labeled, and that's at F. Okay. So then let's take a look at part C. So for here, they want us to list all of the labeled points that are solutions for where x is equal to 0 on the graph of f of x. So we're only looking at f of x, which is again that red line here. So if I'm not sure what does that mean, x equals 0, but I look up here, there's some explanation. So when x is equal to 0, then that's where it's crossing the y-axis, and so we're looking for y-intercepts. So when x is equal to 0, right, we're not going left, we're not going right, so we're staying on the y-axis. So this would be for y-intercepts, right? So we're looking for y-intercepts. Okay, so for f of x, all right, making sure we're paying attention to that part. Okay, so here's f of x, so we're looking to see where does it cross the y-axis, and it crosses the y-axis right here at C. So then that answer would just be the letter C. So part D sometimes can be very confusing to people because it kind of sounds like maybe they're asking for a y-intercept because of that y equals f of x. But what they're asking for is they want you to list all of the labeled points that are solutions for y equals f of x. So that just means, for solutions for y equals f of x, that just means points, well, labeled points, right? So I'm going to say labeled points. Labeled points on the graph. So that's just what they're asking for, labeled points on the graph, okay? So that's solutions for y equals f of x, because x is generic, right? Meaning it's a variable. So that doesn't mean at a specific point, right? Like they don't mean when x is equal to 0, so like C or something like that. They just mean all the points that are labeled. So if I look at f of x, so all the points that are on f of x is really all they're asking for. So that would be A, C as well, right? And then I'm just tracing along here until I get to another point. So there's one. So that would be E. And still tracing. So there's another one, F. So even though it's on both, it's on F. So F is on F. And then last one right here, and then that would be G. Okay, so those would be all of the points that are on the graph. So on the graph. Okay. All right, and then let's take a look at the last one here. So list all of the labeled points, and we are going to add a little point here, or a little sentence. List all of the labeled points on f of x that are solutions for where f of x is less than g of x, right? Where f of x is less than g of x. So that just means where f is below, right? Less than meaning below. Okay, so list all of the labeled points on f of x that are solutions for where f of x is below g of x. So f of x being below g of x, well, that would be, so I'm going to highlight this so we know. So over here, so where is f of x? This is my f of x. Where is it below g of x? So below the highlighted line, so that would be this section here and this section here, right? So that's where it is below. And so anything that is in this pink highlighted region would be my solution. So that would be A, right? So A is below the highlighted line. So A would be an answer. And then if I look here, E is also on that highlighted line, right? So E would be below. And then it looks like, okay, well, what about F? So F is not actually below, it's equal, right? So because this is not underlined, not equal, then I would not include F, so only A and E would be solutions, okay? All right, so let's go ahead and take a look at example 2. So this one is a different type of question, but it's still like really a vocab check. So in this particular problem, we're given just one equation, which is f of x, and then they're going to ask us a variety of things here. So here, they're not asking us for what are the solutions, they're asking for like how many. So is there 5 of these that occur? Is there 2 of them that occur? 1 of them that occur? So just how many, right? So how many times, so how many solutions are there for where f of x is equal to 0? So again, when we say f of x is equal to 0, that means y is equal to 0. So if y is equal to 0, so that's my y-axis, then that means we're not going up or down any. That means we are staying on the x-axis. So then this is an x-intercept, right? So how many x-intercepts, not what are they, but how many are there? So there's 2 of them, right? So there are 2 x-intercepts, so that would be right here and right here, right? So x-intercept, x-intercept. So there would be 2 of them, right? 2. Okay. And then for part B, how many solutions are there for f of 0? So remember f of 0, that means specifically x is equal to 0. And then if x is equal to 0, then that means we are looking for a y-intercept, right? So if x is equal to 0, we're looking for a y-intercept. And again, we're not looking for what is the answer, we're asking for how many y-intercepts are there. So this is my y-axis, so how many y-intercepts? Well, there is 1, just 1 right there, right? That's the only time it crosses the y-axis, so there would just be 1. Okay. All right, and then for question C, so f of 1.34, so this right here, so they want to know what is that equal to? So this, again, that's your x value, right, whenever we put that in that grouping there. So that means when x is equal to 1.34, then what would y equal? That's what that's asking, okay? So, well, I don't know exactly where 1.34 is, right? But if I look here, so I know this is at 1, this is at 2. So 1.34 is somewhere between 1 and 2. So then I am just going to trace that up. So somewhere right around there. That's where x is equal to 1.34. And so what would be that corresponding y value? Well, that would be over here at y equals 3, right? So when x is somewhere between 1 and 2, so right around there, my y value would be equal to 3, right? So it didn't matter where 1.34 was really, right? We knew it was on this constant line, and that was at y equals 3. All right, and then part D. So if you're starting to get this might be a good time to press pause and try to do these last 5 questions on example 2 here. All right, so for part D, they're wanting to know how many, so how many again? How many times does f of x equal 3.5? And so f of x, remember, is just the same as y. So they want to know when y is equal to 3.5, how many times does that occur? Okay. So 3.5, so 1, 2, 3.5, so that would be right around here, right? So 3.5. So if I look to see, okay, how many times is y equal 3.5, so I'm looking how many times does the graph, go through kind of that section there. And that is only going to happen 1 time, which is right here. So again, we're not looking for what x value, but how many, and so that would be 1. All right, and then for part E, so for this one they want to know on what interval is f of x less than 1. So this should have maybe said an open interval perhaps, but they didn't clarify, so we're going to try to answer both ways. So, but because it's strictly less than, that's going to kind of help us with that open interval, right? So strictly less than is going to help us decide, oh, that's probably an open interval as well. So remember, your intervals are x values, right? So whenever we talk to intervals, we mean from the left x value to the right x value, right? That's what that open or that interval means, and then we know it's going to be open because it is not equal, right? So that means that's going to be open. All right, so where is f of x less than 1? So less than 1. So here is a y value, right? So this right here, meaning y is less than 1. So if I look at this particular y value, less than 1, so we're looking at here, right? This is where y is equal to 1 is right on that line, and we want to be below that. So we're looking at this section right here, right? So we want to be below that. So if I look at that kind of ordered pair, so I'm going to make a best guess on that ordered pair. So like maybe 5.5, we're going to just say it's about x equals 5.5 comma 1. And then this one, 8.5. We probably should have put those right on a spot instead of willy-nilly in the middle there. But anyway, that doesn't matter. All right, so if I look at these two dots right here, so that looks like where it's equal to 1. And so I want to be, and again, we just want to go left x to right x. So we're just looking at just the x value alone. That's all we're looking at. So that x value to that x value. Right, so whenever we want interval, we ignore the y value, we just look at the left. And we're going to do open. So again, this is an approximation. So we're going to say from about 5.5 to the next x, which is 8.5, right? So again, whenever we do intervals, we ignore that y value. Okay. All right, so for f, how many roots? So how many roots? So roots, if you forgot, look at the top of the page for your vocabulary review. But roots is synonymous with x-intercepts, right? So x-intercepts. So how many x-intercepts does f of x have? So x-intercepts, so here's the x-axis, so that would be 1, 2. So there would be 2 places where we have x-intercepts, which are also called roots. Okay, and then for part G, and so if you haven't pressed pause, this would be a good time, so G and H, so try that. So on what interval is f of x greater than or equal to 3? So f of x greater than or equal to 3, so 1, 2, 3, so that would be right here, this section. So there's actually going to be 2 places, right? So let me get out another highlighter color. So I'm getting a lot of highlighters in here. Okay, so f of x greater than or equal to 3. So because of that equals, right? So we have that kind of equals, oh, that is not a highlighter. Okay, that was a permanent pen. let me get a highlighter. Sorry about that. Highlighter, here we go. That was a marker. Okay, so f of x greater than or equal to 3. So because we have that greater than or equal, that means we're going to have a closed interval because it's equal. So we'll be using brackets on that, right? And we want to be above it. And again, we're doing intervals, so that means we're going to do left x to right x. Okay, so where is 3? So this is 3, so I want to be equal to 3, right? And I want to be greater than or equal to it as well. So that's going to be this section as well. So we have 2 places that we're looking at. And so that means we're going to have 2 different answers because they're not connected, right? So this section is where it's equal to 3, 1, 2, 3, constant. And then this one right here is where it's above 3, right? So this little forever mark there. All right, so we have forever, it goes to the left. So this is going to be negative infinity on that one. And even though it's a closed interval, we can't ever include infinity. And then it's going to stop at this ordered pair, which looks like it is at 5, 3. So it stops at that little dot there, so at 5, 3. But again, when we talk about intervals, we only use the x value, so it's going to stop at 5, and it's going to include it, right? Because it's equal to right there. And then we have another section, so I'm going to use that union. And so this one over here. So that one starts at this dot, that ordered pair, so let's figure out what that one is. 9, so at 9, so that dot is at 9, 3. So again, we ignore the y, we use just the x whenever we talk about intervals, and we're going to be closed because it's equal. And then it doesn't stop, right? So if it doesn't stop, then it's going to go to infinity. Okay. All right, and then the last one here, so h, is f of x equal to 0, somewhere between 5 and 7. So let's go to where x is 5 and x is 7. Let's start with that. So 5 is right here, and 7. So is f of x equal to 0? So remember, f of x equaling 0 means that y is equal to 0. And if y is equal to 0, that means we are looking at an x-intercept. So is there an x-intercept somewhere between 5 and 7? And there is. There's one right there. So then the answer to this would be yes. Okay? All right, and then let's take a look at the last page, so page 2. So this one for sure is just kind of a recap of what the front side was. So then, you should definitely, if you haven't already, press pause, try to do this last problem, and then just check your answers. So specifically here, so we are going to be saying, are the statements true or false? And so if it is true, we're going to use the letter A, and if it's false, we're going to use the letter B, okay? So again, just a reminder, if it is a true statement, we're going to use the letter A, and if it is a false statement, we're going to use the letter B, okay? So we're going to make sure we're doing that. Okay, so they want to know, is f of 4 greater than 0? So this is my x value. So when x is equal to 4, what is the y value? Okay, so when x is equal to 4, so this is my x-axis, there is the ordered pair right here. And so is that y value is around 0.5, and is that bigger than 0? And it is, right? So that is a true statement. So we would say A for true, right? Okay. All right, for part B, is f of x, or excuse me, f of negative 2, is that greater than 0? So again, this is when x equals negative 2, and then I want to know what is that corresponding y value. So I'm going to go to x is negative 2, so that would be right here, and then I'm going to go to that ordered pair, so to there. And so that y value looks like around negative 2, and is that a number bigger than 0? And it is not. So is f of negative 2 greater than 0? No, it's down here, negative. So that's a false statement, so then I would use the letter B. Okay. So if you're getting this, again, you should be pressing pause, trying it, and then check your answers. Okay, so for right here, so my x is equal to negative 1. And then what they want to know is that equal to 0, right? Is that equal to 0? That's what they're asking. So when I go to where x is equal to negative 1, so that would be this dot right here, my y value is 0, right, because it's on the x-axis. So then that would be a true statement. So then that would be a true statement. We use the letter A. All right, B, or excuse me, D, letter D. Okay. So this is saying that x is equal to 2. And they want to know, is your y value equal to 0 when x is equal to 2? Is that true or false? So when I go to where x is equal to 2, so that would be right here, my y value is negative 1, not 0, so then this would be false. So I would use the letter B. Okay. And then 4.123, so 4.123, so that would be somewhere around here. And then when x is 4.123 and I go up to that corresponding y value, does that look like it's about 1/2? And sure, it looks like it's about 1/2 to me. So then I would say true, and I would use the letter A. Okay. All right, so if I go to y is equal to 0, so y equals 0, so that would be here, right? This is my y-axis right here. Does it occur at f of negative 3? So at x equals negative 3. So if I go to negative 3, so that's right there, and my y is equal to 0, and that looks very true to me as well. So that would be the letter A for true. All right, and then G is f of x equal to 0 between 2 and 3. So f of x equaling 0, so that means the y value, right? Because f of x is y. Somewhere between 2 and 3. So here's x equals 2 and x equals 3. So is there a x-intercept, right? Because that's what that's asking. When y is equal to 0, that means x-intercept. Is there one somewhere between 2 and 3? And sure, there's one right there, so that would be true. Does f of x equal 0 exactly twice? And remember, 0 is synonymous with x-intercept, right? So that's that vocab review. So does f of x equal 0, meaning does it have an x-intercept exactly twice? So that would be 1 here, and 1 here, so that would be false, because that's 3, right? 1, 2, 3, so that would be false. Okay. All right, and then for I, so f of x has a relative minimum at 0, -2. So that would be at the ordered pair 0, -2. So over 0, -2. So right here, is there a relative minimum? And there is nothing there, right? So at that ordered pair 0, -2, there is absolutely nothing on the graph there. So that would be false, so that would be B. Okay. All right, and then finally the last one, J. So f of x has a relative maximum at the ordered pair 3, 2. So 3, 2, so that would be this guy right here. And that would be true, right? So relative maximum definition, remember, is when the graph goes from increasing to decreasing, and that is definitely happening there. So that is a true statement, so then that would be the letter A. Okay. All right, so that's it for the new stuff, and then we have a few solving review problems here just to kind of make sure that your solving skills are on par here. So let's go ahead and do some of these to review. So for number 1, so we are looking at solving this. So in order to solve this, we would make sure this is equal to 0, right? So if I want this equal to 0, I'm going to add the 5x over to this side. So I'm going to do this in 2 lines, even if you could do this in 1. So then that would give me 7x. This would be 0, and then equals 18. So it's still not equal to 0 yet, so I would subtract 18 now. And then as soon as it's equal to 0, I would go ahead and try to factor to solve this, okay? So for factoring, I'm going to do guess and check. So I know x squared would factor to x and x. And I know my factors of 18, so I'm just going to kind of list those on the side over here. So for factors of 18, I could use 1 and 18, 2 and 9, 3 and 6, and I'm looking to try to get a 7x. And keep in mind that one of those numbers has to be negative in order for it to equal -18. And so then that would be, let's see, so 9 and 2, right? I would use 9 and 2, and then the 2 would have to be negative in order for it to turn out to be a positive 7. So then this would be a -2 and a 7. And then I would go ahead and solve each of those using the 0 product property, because this is a product equal to 0. And then add 2 over, so I would get x equals 2, and then subtract 7, and I would get -7. So then x would be either -7 or 2. Okay. All right, and then let's go ahead, and I'm going to jump to number 4, okay? So when I look at questions number 1 and 4, so there's multiple x's, so I know that I have to equal it to 0 to solve it. Here there's only 1 x in that whole problem, right? So if there's only 1 x in that whole problem, remember what I want to do is I want to isolate the squared term, and I want to solve by square rooting, okay? So I cannot add the 12 and the 3, I have to solve it by moving stuff to the other side, doing inverse properties. So I'm going to subtract 12 from both sides. And then divide by 3. And then I'm going to square root. And then that turns into absolute value, right? And then from there, I'm going to create my 2 equations. So I have x minus 3 equals root 2. And then x minus 3 equals negative root 2. And then add 3 over, and I can't actually add it, right? So we always want to put that first, and root 2 is positive, so it'll be 3 root 2. And then over here, add 3 over, so that should go first, and then this is negative root 2, so negative root 2. And somehow, I wrote 2 root 2. I think I was talking as I was writing, so this is, let me correct that, sorry. So then that would just be 3 and then minus the square root of 2. And then these are conjugates, right? So I have the same terms, one added, one subtracted. So I could also write my answer as 3 plus or minus root 2. Okay. All right, so then I'm going to backtrack then to number 3. So we're going to take a look at that one. And so for solving here, I would go ahead and solve this. So I'm going to, again, isolate the absolute value because there's only one x here, right? So we're going to isolate that absolute value. We want that by itself, so I have to get rid of that 5 and that 3. So again, I cannot add these together, right? Can't write 5 minus 3 is 2. I have to move the 5, move the negative 3. So I'm going to subtract 5 from both sides, so we want to do that. So I'll still have that negative 3. And then negative 9. And then divide both sides by negative 3. And then when I have that absolute value, I'm going to create 2 equations there. So I'm going to have 2 equations. So we're going to do x minus 7 is equal to 3. And then the negative version of that, so this would normally be negative, but remember we're just always dividing that over, so that would just be negative 3 there. And then now I'm going to go ahead and add 7 to both sides. And the same over here, add 7 over here. So I have 2 answers, x is equal to 4 and 10, and that's all we would have, okay? All right, and then for this last one, I'm just going to get started on this one right here, because I don't know how in depth we would actually want to go through the process of, solving this, cubic, because all we were doing earlier was just factoring. So even though it does tell us to solve it, we're just going to practice that factoring. So for that factoring cubic, just a reminder, we would have the a would be x, right, because the cube root of that is just x. And then my b value, so the cube root of 64 would be 4, right? And that's because 4 times 4 times 4 is 64. So then my factoring, so we would have a binomial, remember for factoring, and then a trinomial, binomial and a trinomial. In my binomial, we're going to put x and 4, keeping the sign the same, right? Same, opposite, always positive. So x minus 4, keep that sign the same, and then we're going to square, multiply, square, square, multiply, square. So we're going to square, so x times itself, and then we're going to multiply. X times 4 is 4x, but then opposite sign, so opposite meaning plus, and then square again. So square the 4, so 4 times 4 is 16, and then this last one is always positive. So we didn't actually do any solving, right? We just factored. So normally we would say, oh, okay, keep solving, but for this particular chapter, we kind of eliminated that component, and so you're not going to have to solve, but you could solve this one pretty easily, right? So you would do x minus 4 is equal to 0, so x would equal 4. And then we didn't ask you to do quadratic formula with imaginary numbers on this one, so we're going to just pause on that. Okay, and that's it.